Integration of vector functions. Question number 1, choose the correct answer from those given. Question number 1, if v equals 8t plus 5 and x of 0 equals 7, then x of 4 equals 91, 77, 49, or 25. So we have v equals 8t plus 5 and x of 0 equals 7, and the required here is to calculate x of 4. The required here is to calculate the position after 4 seconds. Solution, we have v equals 8t plus 5, and from that we can calculate x is the position. So x equals integration of v with respect to d, with respect to the time. So x equals integration of 8t plus 5 dt. What is the integration of 8t? It is equal 4t squared. We increase 1 to the power, so we have t power 2, and divide by 2. So 8 divided 2 equals 4. So we have 4t squared. The integration of 5 with respect to the time equals 5t, equals 5t. Of course, plus c, it is the constant of integration. Now we want to calculate the constant of integration, which is denoted by c from the primary conditions. Here we have at the beginning when t equal 0, x naught equals 7. When t equals 0, here x equals 7. So we write x of 0 equals 7, then substituting t equals 0. So we have 4 multiply 0 power 2 plus 5 multiply 0 plus c equals 7. And from that you can deduce that c equals 7. C equals 7. So x in terms of the time, in terms of t, equals 4t squared plus 5t plus 7 here. But the required here is to find the position or x of 4. So substituting x equal 4, what we get? 4 multiply 4 squared plus 5 multiply 4 plus 7. Using calculator, you will get x of 4 equals 91. And the answer is A here. Second question, question number 2. If A denoted for the acceleration, if A equals 4t plus 3 and V2 equals 20 meter per second, then V naught equals one of these choice. 3 or 6 or 9 or 20. V2, how you get the velocity from acceleration? By integration. We know that A, it is acceleration, equals dv by dt. So the integration of dv equals integration of a dt with respect to the time here. So we'll use this form. A equals, it is given since A equals 4t plus 3. And also we know that V equals the integration of A with respect to D. Again, V equals integration of A dt. We substitute V equals 4t plus 3 and we start integration. Of course, we make the integration with respect to the time. So the integration of 4t equals 4t squared over 2. Okay, so the result equals 2t squared here. What is the integration of 3 with respect to t? Equals 3t. Of course, plus the integration's constant c. Now we want to determine the value of c from the primary conditions. Here we have V2 equals 20. V2 equals 20. It means after 2 seconds, the velocity becomes 20. So substituting t equals 2 here and the velocity equal 20, you can calculate it. You will get c equals 6. Here, when you use a calculator, you can use this method. Here we have 2 multiply 2 power 2, 2 multiply 2 power 2 plus 3 multiply 2 plus c, it is x, equals alpha. Here alpha calc, you will get equal. Don't write equal from here, and the result equals 20. Now we want to solve for x. What is the value of x? So shift solve. The result here equals 6, and here we can write c equals 6. Okay, so what is the value of the velocity? V equals 2t squared plus 3t plus 6. Here, don't forget, V equals 2t squared plus 3t plus c. And we deduce the value of c, it was 6. So we have V equals 2t squared plus 3t plus 6. Now the required is to find the V naught. V naught, it means V when t equals 0, when the velocity equals 0. So substituting V equals 0 as t equals 0, so we will get V equals 0. Of course, 0 power 2 is 0. Multiply 2 equals 0. Plus 0 plus 6. So V naught equals 6. And the result, or you can say the answer is B here. Next question. Question number 3. Here the question is, the particle has space equals 0 at maximum height. The particle has c equals 0 or v equals 0 or x equals 0 or d or t equals 0 at maximum height. Of course, if you have a particle moves in this direction, vertically upward, at a certain moment it will stop. Here is the maximum height, and here let it starts from the ground here, and here is the maximum height, and it will return back once more. So at this position, V equal 0. So you can say the particle has velocity equal 0 at the maximum height, and the answer, the letter B. Next question. The particle has equal 0 at maximum velocity. At maximum velocity. At maximum velocity, here you consider the velocity is uniform. It is fixed speed, fixed velocity, no acceleration. So you can say that the particle has A equal 0 at the maximum velocity. At the maximum velocity, the particle moves with uniform velocity. Uniform velocity. So the acceleration equals 0, and the answer will be letter A. Here is the second question, fifth question. A particle moves in a straight line from rest. Okay, from rest, what does that mean? From rest, it means V equals 0. Here, V naught equals 0. When T equals 0 at the beginning, V naught equals 0. That is the meaning of the particle moves in a straight line from rest. Okay, from the origin point O. Here, you must consider x naught equals 0 also. From the origin point, at the origin point O, x naught, the position vector, equals 0. So you always put the position equals 0 when they say the particle moves from origin point or fixed point or constant point. It is the same meaning. Starting from x naught equals 0, the position vector equals 0, such that A, it is the acceleration equals A minus 3t squared. Okay, then it reaches the maximum distance at t equals, here they ask about the maximum distance. Maximum distance. Before it reverses its direction. So imagine that the particle starts from here when x equals 0. For in this direction, and then here when it will reverse back in this direction, here what is the value of v? In this point v equals 0. At this point v equals 0. So here then it reaches the maximum distance. Here it is the maximum distance. And we wanted to calculate it, the required distance. Before it stopped, why the particle stopped? To reverse, to change its direction. From this direction here to get back again. So at this point, V equals 0. Now, we must calculate V and know when it equals 0. How you get V from acceleration? Integration or differentiation? Of course, it is integration. So we write, it's very important. When t equals 0, V not equals 0, because they said start from rest, and x not equals 0, because they said in the problem, in the question here, it starts from the origin. A equals 9 minus 3t squared. So the body reaches the maximum distance when V equals 0. Okay, I explained it here. So we must calculate the velocity. We know that A equals dv dt, right? Here, A equals dv dt. Okay, so the integration of dv equals the integration of A dt. It means V equals the integration of, what is the value of A? From the question here, A, it is 9 minus 3t squared. We write it. V equals the integration of 9 minus 3t squared dt. And you complete. V equals 9t minus, what is the power of t squared in integration? It will be t power 3. And we divide once more by 3. So we have V equals 9t minus 3 over 3, t power 3 plus the constant of integration. How we determine the value of C? Using the primary conditions. What is the primary conditions? When t t equals 0, v equals 0, v not equals 0 here. So 0 equals 9, multiply 0 minus 0 power 3 plus t, it means c equals 0. Now, v equals 9t minus 3 divided 3 equals 1, t power 3. So, we must put v equals 0. Here, v equals 0. Once more, don't forget this figure. Okay? So, when v equals 0 here, and we factorize the right-hand side, so we will get, you can take t as a common factor here, t, and the 9t divided t equals 9, negative t power 3 divided t equals negative t square, and to complete solution here, we write t. Here we have difference of two squares, 3 minus t multiplied 3 plus t equals 0. It means t equals 0. Of course, it is at the beginning, or t equals 3, or t equals negative 3. When 3 plus t equals 0, so t equals negative 3, of course, it's refused. Here, it is refused. So the body will change its direction after 3 seconds. When t equals 3, and back to the question here, and you will choose letter C. Next question, number 6. A particle moves in a straight line starting from the origin point. What does that mean? X naught equals 0. Okay, with velocity v. It is v naught here. V naught equals 6t plus 1. Then the displacement covered within the time interval 0 to 4 equals. The required here is to calculate the distance. The displacement. Of course, there is a difference between displacement and difference. Okay. We know that here, first we must write the primary conditions. When t equals 0, x equals 0, and v naught equals 6t plus 1. So dx dt equals v. Using integration here in left hand side with respect to x, and right hand side here with respect to t. So the integration from x naught to x dx equals the integration from 0 to 4. Here is the interval from 0 to 4. We write 0 to 4 v dt. And what is the value of t in terms of v in terms of t? We can substitute. The integration of dx is x from x naught to x. Integration from 0 to 4, and you substitute v equals dt plus 1 dt. So the result of integration equals 3t squared plus 3 plus t plus from 0 to 4. The integration of 6t squared, it will be 6t squared over 2, which equal 3t squared here. And we write 3t squared. Integration of 1 dt equals t. Okay. So you substitute once at t equals 4. So we have 3 multiply 4 power 2 plus 4 minus 3 multiply 0 squared plus 0. And you will get 52 here using calculator. Of course, in this question, you can use calculator to find the value of this integration. Okay, here we will choose this integration, and we write the function we have. We have 60 plus 1, 6 x plus 1 from what? From 0 to 4, okay, equals 52. And this is the result of the integration. And we will use it here, letter D. Letter D. Next question. Question number 7. A particle moves in a straight line with constant deceleration. A equals negative 9.8 meter per second square, and its initial velocity V naught here equals 19.6 meter per second. Then the velocity vanish at t equals, then the velocity v equals 0. That is the meaning of vanishes. When t equal after how many seconds? So we write, we have A equals negative 9.8 meter per second square. It is a given. V naught at the beginning, it is the initial velocity. When t equals 0, V naught equals 19.6 meter per second. Okay, so we have this rule, A equals dv dt. So V equals integration of A dt, and V here equals negative. What is the value of A? It is negative 9.8. Here, A equals negative 9.8. So we write negative integration 9.8 dt. The result will be negative 9.8 t plus c. It means V equals negative 9.t plus c. Now we want to calculate the value of this constant from the first conditions, the primary conditions. When V equals 19.8, again, when t equals 0, the velocity was V naught equals 19.6. Okay, so 19.6 equals negative 19.8 multiply 0 plus c. It means c equals 19.6. It is a constant. Okay, so we substitute the value of this constant in V here. So we will get V equals negative 9.8 plus 19.6. Okay. What is the required? The required here is to calculate the time when the velocity equals 0. So substituting V equals 0 here, it is the value of V. Substituting V equals 0. So negative 9.8 t plus 19.6 equals 0. It means t equals 19.6 divided 9.8 equals 2 seconds. What does that mean? That means that the velocity will vanish after 2 seconds. After 2 seconds. Okay, again, you can use calculator to calculate this, to calculate the time of t. Here, you can use your calculator to solve the first degree equations here. This method, it is very good for the first degree equation, the linear equation. when t when the power equals 1, not when the power equals 2. Okay? Okay. So let us write it here. Negative 9.8. Instead of t, we write x. So alpha x plus 19.6 equals 0. Okay, don't press equal. We wanted to solve for x. We wanted to solve for t. So shift solve. It is this answer for the previous question. So we must press equal here. The result equals 2. So t equals 2. Okay. Question number 8. Here we have 3 requirements. Okay. If v equals 16 minus 40 meter per second and x naught equals 3, then x of 5 equals how many meters? 3 or 13 or 33 or 49? It is the first. We have 1, 2, 3, 4 requirements. Okay. Let us start with 1.